exposed to logicals, and we've seen that they are usually 1 or zeros, yes or no, true or false. But in how, they are represented with T and F, or true, false, any of the two. The same way we created this, you are going to do that. Then you pause the video, you do that, you create a logical variable of the size 100 and you sample it to make it random. Then after, we'll do it together. Well, I hope that went well. I'll set my seed first, set it to 1 to 3, and now I will duplicate true, the object true, false 100 times of 50, so that's twice. Yeah, so we have 100 like that. Now next, I need to shuffle this and truly randomize it. So I'll set replace to true. Then we have customer response true, and now we can run this. I'll run the seed again, then check customer response true. Now we have this. Now we use some functions for the logical data type which we've just created, customer response to. Do not be surprised if we can get the total number of people that said yes and no from this. Of course, we can use table that we saw earlier, customer response to, and it will give us a quick result. But the other thing which we can do is we can use the sum function, and we use it on customer response to, and see that we have 57. And now we get surprised that the length of this customer response to is 100, and now the sum is 57. How is that possible? One way to see what is happening under the hood is to change customer response to integer. The integer function, pass customer response to that. I'll see we have 111 with ones being for the part that true appeared and 0 being for the part that false appears. What this does is it simply adds all the 1, and anything plus 0 is that thing. -1 plus 0 is -1, 1 plus 0 is 1, and that's why we can perform such operation on logical. When logical data type was introduced, we said they are integers under the hood, and now we can see that indeed they are integers. We can also perform other operations. For example, now we've seen the sum. We can get percentage of people that said yes in our response. And what we do in this case is we use the mean, then we pass in our data in between that, and we have 0.57. Now we might be surprised that, okay, but this is not 100%. Actually, it is. If we check, if we do this rep force 10 times, I need to sample, I'll check the mean, we see that it's 0, and this implies 0%. If this is true, is 1, which means 100%. So we can take 0.57 as 57% and 0.1 as 10%. So what we have here is 0.57, which is 57%. You can as well multiply it by 100 to see this as 57%. A quick way to get percentage is using mean over the logical response. Do not be surprised if you get to use this a lot later in the future in your analysis.